topic. Our topic is formula relevant to trigonometry. So when we talk about trigonometry, it is something that is very people might think or student might think that it is hard, but don't worry. I'm here to explain to you to make it easier. So in this topic, what we're gonna cover today is the basic trigonometric functions, the SOHCAHTOA, the reciprocal trigonometric functions, the Pythagorean identities, the angle sum and difference formulas, and the law of sines and cosines. So, um, today, okay, so let's start with the basics: sine, cosine, and tangent. Remember SOHCAHTOA. Sine is the opposite, so this is the sine. Yeah, its formula is opposite over the hypotenuse. So this is the opposite over the hypotenuse. And then ka, which is the cosine adjacent over hypotenuse. So cos theta is equal to this, the adjacent over the hypotenuse. And TOA, which stands for tangent opposite over adjacent. So in tan theta, we have the opposite over the adjacent. Okay, so here is the so now let's go to the its reciprocal. So the reciprocal of the SOHCAHTOA. The reciprocal of trigonometric functions. So in secant theta, we have 1 over cos theta. The cosecant theta is equal to 1 over sine theta. The cotangent theta is equal to 1 over tangent theta. So it's very easy because it is just the inverse of the first trigonometric functions. So we have here the examples which you can browse this. You can just go back to these videos if you want to see more on the given examples. So here we have the Pythagorean identities. So the sine squared theta plus cos squared theta is equal to 1 can be derived in 1 plus tan theta squared theta is equal to sec squared theta, and 1 plus cot squared theta is equal to cosecant squared theta. The Pythagorean identities are fundamental trigonometric equations derived directly from the Pythagorean theorem, which is the a squared plus b squared is equal to c squared, applied to a right-angled triangle or to the unit circle. They express the relationship between the sine, cosine, tangent, secant, cosecant, and cotangent of an angle. So in angle, sum, and difference formulas, we have here the sum formula and the difference formula of the three trigonometric um, identities. So in sine function, the sum formula is sine a plus b is equal to sine alpha cos b plus cos a sine b. And in difference formula, we have sine a minus b is equal to sine a cos b minus cos a sine b. So in cosine functions, the sum formula is cos a plus b is equal to cos a cos um, b minus sine a sine b. And then the difference formula is we have the cos a minus b and then cos a cos b plus sine a sine b. In tangent, we have tan a plus b is equal to tan a plus tan b over 1 minus tan a tan b. And then in difference formula, we have the tan a minus b is equal to tan a minus tan b over 1 plus tan a tan b. So, yeah. Now, let's go to the law of sines and cosines. So, um, some of the triangles are not always right triangles, but do not worry because the law of sines and cosines will save the day. So, the law of sines is a trigonometric law that relates the lengths of the sides of any triangle to the sides of its angles. For a triangle with sides ABC, here ABC, I mean, and opposite angles ABC, the law is given by sine A over A is equal to sine B over side C, sine C over side C. This law is particularly useful for solving triangles, especially when given a certain angle measures and side lengths. The law of sines is a fundamental tool in trigonometry and is applicable to both acute and obtuse angled triangles. Now, the law of cosines. The law of cosines is a trigonometric law that relates the lengths of the sides of a triangle to the cosine of one of its angles. For a triangle with sides A, B, C, and angle C opposite to C, the law is given by C squared is equal to A squared plus B squared minus 2A times cos C. But here are other formulas depending on the value that you want to find. Um, we have here a plus a squared is equal to b squared plus c squared minus 2b times cos a. And then b squared is equal to c squared plus e squared minus 2ca times cos b. And then again, if you want to find the side c, we have c squared is equal to a squared plus b squared minus 2ab times cos c. This law is a generalization of the Pythagorean theorem and is particularly useful for solving triangles when three sides of two sides and an included angle are known. The law of cosines is widely applied in geometry and navigation. So that's all. Thank you very much for watching, and I hope you've learned from the video.